No, it is tangent. But you don't know the angle. You know, opposite is what over here?
That's 4.
4, correct. What's the adjacent?
3.
So what do I have to do to get my angle back? Not divide. Because this theta is locked in here. You can't get rid of it. This is not like you can just divide out or something. How do you get that theta back? Can you still see that? Let's see what my limits are here. Oh, barely. What do you do?
I want to say inverse tangent.
Yes.
It's all time.
What happens to this?
Cancel out.
Just cancel out, you get theta back. Calculate. Let's see. Make sure your calculator's in degrees, if that's what you're working in. So 4 divided by 3 equals 4/3. 1.3 repeating. So arc tangent, where's my arc tangent? There it is. Mustard button plus answer equals 53. This is 53 degrees. That's what that equals. And if you wanted to check it out, you can work backwards. You can take the cosine of 50. You guys see that? You can take the cosine of this angle. So cosine of answer equals 3/5. And that makes sense because if you multiply it by 5, which is the length of this, you get 3 back. And that is the x. So you see it works. You guys see that? Is it obvious how to add these and subtract these? Yeah. Is it now obvious how to convert them? Is it obvious if you know this, the Cartesian, and you want to put it in radial form, is it obvious what you need to do? You need to use Pythagoras to find the length, and you need to use the arc tangent to find the angle. And we're going to be doing a lot of this for the rest of this chapter, because now we're doing mechanics. The stuff that we were doing last chapter, we're doing in 2 dimensions now. Okay? Is there any questions? No? Go ahead and let me make one more comment. If you're studying physics, you're studying on a problem, it's best to choose the coordinate system that matches the problem. So if you're talking about a car driving and dragging some weight and there's mass getting pulled down, how do you want to line that up to make the math simple so you don't have to kind of convert between the angles or anything like that? Would you define your coordinate system like this? Why not? Can you have your coordinate system twisted like this? Yes, you can. But why would you not do that for this problem? Yeah, because it's moving the x and gravity's acting on the y. So you want your coordinates to be parallel or perpendicular to those things. Now, what if we have a wedge and we have a block sliding down the wedge? What would you do then? You put a little gangster lean to it. Now, it's not all going to be perpendicular to these coordinates because gravity is working in this direction. You see this is not parallel or perpendicular to either one. But guess what? Its motion this way is, and the friction pulling back in this way. And also the normal force pushing back on the block from the wedge is also in that direction. So you want to pick, according to your problem, you want to pick what angle. Okay? Now do the questions on page on page number 94, 1 through 4. And then have a good weekend after that.
So if we don't finish that, we can't have a good weekend.
No.